Use the coil tool. In this video, we'll create a coil feature and we'll use a coil to drive a sweep cut. In Fusion 360, we want to get started with a new untitled document. I'm going to be using a metric document, so all of my values will be in millimeters. To get started, we want to create a new sketch, and I'm going to be using the XY plane. A center diameter circle placed at the origin with a diameter of 50 millimeters, and then we'll finish the sketch. From here, we want to use Create Extrude and extrude this up a distance of 100 millimeters. We've now created a solid cylinder. We're going to explore the coil tool as a use to create physical threads. So under the Create dropdown, we're going to navigate down to the area where we have our primitives and select Coil. When we create a coil, we first need to select a plane, and then we need to draw a center diameter circle. Once again, I'm going to draw a center diameter circle set to 50 millimeters. Once we do that, you can see a preview on the screen of what's going to be created. At this point, we need to begin defining what our coil is going to look like. First, we can define it by a specific type. By revolutions and height, revolutions in pitch, height and pitch, or set it as a spiral. We're going to be using revolutions and height. The diameter is going to stay 50 millimeters based on our sketch, but we could also modify that. We're going to set the number of revolutions at 6, keeping in mind that we don't want to hit the Enter key before we're done entering the values in this dialog. We're going to set the overall height at 95 millimeters. The angle is going to stay 0, and we want to change the section from circular to triangular internal. From here, we also want to affect the section size. Right now it's set to 12.5 millimeters, but we're going to reset this to 5. Note that this also can be created as a cut, a join, an intersect, or a new body or new component. We're going to create this as a new body, but note that it can be used directly to simply cut or remove material from another solid body. We're going to say OK and expand our bodies folder and rename body 2 to be our coil body. From here, you might be wondering why we're even bothering to create a coil and a cylinder if we simply want to create a thread. If we flip the triangular profile around to the external side, we could simply use that as a thread, but there are some differences that we want to make sure that we are aware of. When we're creating a thread, we need to be mindful of the starting position and its relationship to the solid we're removing it from or adding it to. In this case, the coil is going to start, if we view this from the right-hand side, at this position that's directly centered on our object. We might need to create a profile that is not completely in line with our XZ plane. We want to make sure that we're aware of this when we begin creating our new part. So for now, I'm going to hide body 1 and focus my attention just on the coil. The first thing that I want to do is go to Construct and create a plane along a path. I'm going to select the internal section, and I'm going to bring this all the way back down to 0. This plane, if we view it from the right-hand side, is different from the external face of our coil. This is going to be normal to the direction that we're going to be cutting or removing material. So we're going to say OK on that new plane. The next thing that we want to do is determine what the shape we're going to be removing from our geometry is. At this point, we're going to be using our plane to create our profile. We're going to be using this inside edge to drive the profile on a sweep and the outside edge as a reference. But for now, we can hide the coil body and bring back our original body. We're going to start a new sketch. And notice that the origin point is based on that center point that we use to define the plane. So we have this reference and we can determine whether or not we want to simply use a polygon or some other geometry to remove. In this case, we're going to use a polygon. We're going to start and begin drawing this out. And notice that this is creating a polygon with multiple sides. In order to create the polygon that we want, let's start the tool again. And we're going to go over to this edge number and set it to 3. Once we create that edge number, we can begin defining it. In this case, we can define it however it needs to be based on our requirements. I'm going to use D on the keyboard to set the value, And I'm going to begin by setting this to 20 millimeters. I'm going to hit escape, and then I'm going to use horizontal vertical to set this as vertical. From here, we now have our profile, we have our solid geometry, and we have our coil body that'll help us drive this cut. So from here, we can go into our Create menu and select Sweep. First, we need to determine the specific type of sweep that we want. Ours is going to be a path and a guide surface. First, we select our triangular profile. The path is going to be that inside edge of our coil, and our guide surface is going to be the outside. This is going to allow us to create the sweep that goes along the entire profile. Note how it's going around, and there are some areas where it's overlapping, but because we are removing it, we don't have any problems with the geometry. If we were trying to make a solid that had an exact fit here, this might become problematic. There are other options that we might want to consider as well. There is an analysis section that allows us to analyze the bodies. In this case, none can be turned on, but we can also use things like zebra stripes or curvature maps or even ISO curves to view what the cut is going to be. In our case, I'm going to set this to none and say OK and allow it to remove that geometry. Once we've removed the geometry, we have to be mindful in the fact that what we've actually done is we've removed it from the original body, and if we didn't select it, we've also removed it from the coil body, and any remnants will be shown. This is a very simple example to show you how to use a coil tool and how that can be used to drive custom threads. In most cases, a custom thread might have more of a square profile, or maybe is just not a standard pitch that you can find by using the standard tools like hole or thread. But if you come across that, you can always use coil to create those custom geometries. There are some limitations and drawbacks to this tool, but oftentimes it will allow you to create that geometry when the hole or the thread tool just doesn't have exactly what you need. At this point, let's save this design. I'm simply going to call it coil thread, and then we can move on to the next step.